For Math 251, solutions. First problem, you're given this mess of a graph, this graph with lots of different discontinuities. And asked to evaluate a lot of limits. These are big because when I first looked at it, it was hard to tell if these were from the negative or positive side. At any rate, this is asking you to figure out the limit as x approaches -2 from the negative side of this function f of x. So here's -2 right here, but if you're coming from the negative side, you're coming from this direction. So you're somewhere right around here. It looks like the height is just about 2, so the answer would be 2. However, as you approach -2 from the positive side, so now you're coming in this direction, looks like the height is -1. And then finally, if it just asks you the limit as x approaches -2, well, anytime the two one-sided limits don't agree, you would say this does not exist. If you're curious, it's because, well, I'll just say it instead of writing it. It's because this and this are different. The limit as x approaches 0. Well, here's 0 right here, and when we get close to 0, looks like the height gets really, really close to 1. The fact that this is a closed circle versus an open circle or something else is completely irrelevant. Height gets close to 1, the limit is 1. What about the limit as x approaches 3? Well, here's 3 right here. When we get really, really close to 3, the height gets really, really close to 0. Not -1, that's the height at 3. Limits aren't concerned with the height at that point, just at points close to that point. In other words, the height is 0. Okay, maybe a little bit more challenging or a little bit more work to be done on these down here is we're evaluating limits using the methods of section 2.3. So what you want to do is make the, first of all, this shouldn't say f of x. All right. Probably go back and clean this up a little bit before I give you guys the quiz. I think that was me being lazy and cutting and pasting. It's asking for the limit as x approaches 3 of this whole mess right here. And the way you can figure that out is the problem with this is it's discontinuous when x equals 3. But I can find another function, another expression, that has the exact same limit that's not discontinuous at 3 if I can cancel out this x minus 3 with an x minus 3 from the top. And I can do that if I can rewrite the numerator as x minus 3 times something else. Well, that something else is going to end up being, well, let me show you how you can figure out what's up top. I could factor by grouping to take this 2x cubed minus 6x squared plus 3x minus 9. My first group, these first two terms right here, appear to have a 2x squared in common. If I pull out that 2x squared, I'm left with x minus 3. And if I want to be left with an x minus 3 from these terms, I better pull out a 3. And so what I have are two terms here separated by this plus that both have an x minus 3 in them. So if you factor out that x minus 3, what you'll have left is the 2x squared plus 3. Anyways, the numerator factors into this thing. You don't have to do it that way, but there's one way you can get it. So I can now cancel out this x minus 3 and this x minus 3 to get to this limit. This limit up here is the same as the limit as x approaches 3 of 2x squared plus 3. A little bit careful here. You can only put this is not the same as this. They're only the same if you have these limits written right here. So it's important that you tack these limits on in here, something that often gets missed. The other point I want to make is I can evaluate this limit because this function is continuous at 3. So I can evaluate the limit just by changing all the x's into 3's. I can say that this is equal to 2 times 3 squared plus 3. 3 squared is 9 times 2 is 18 plus 3. Looks like this limit right here would be 21. Next problem, these fractions inside fractions ones. I think you've gotten a little bit of practice with these. Again, I want the limit as x approaches 3. And the trick on these ones is to take the numerator of this big fraction and make it all one fraction, or rational expression if you really want to use the technical terms. And so I don't have the same denominator, so I can't subtract these two guys, but I could get a common denominator by multiplying this side by 3 over 3. That would give me 3 over 3x, minus, and multiplying this side by x over x. Gives me x over 3x. And the reason that's helpful is now I can subtract the numerators here. I have the same denominator, so I just do the 3 minus x and divide that entire thing by my common denominator of 3x. And then note that is all divided by x minus 3, which I'm going to write as x minus 3 over 1, so it looks more like a fraction inside of a fraction. Maybe I'll hop over here and say that that's equal to the limit as x approaches 3 of, well, I know how to divide fractions. You can change it into a multiplication of fractions problem if you multiply by the reciprocal of the denominator. You can almost cancel out. I got an x minus 3 and a 3 minus x. This is what I'm trying to get rid of. You can cancel it out if you're a little bit clever. And note that 3 minus x is just the negative of x minus 3. So if I cancel out this x minus 3 and this x minus 3, I get this is the limit as x approaches 3 of negative 1 divided by 3x. And the nice thing about this is it's continuous at x equals 3. So I can evaluate the limit just by changing all the x's into 3's. In other words, I get negative 1 over 9 as my limit. All right, one more. The square root problem. When you see the square roots, the trick that we have for these is we're going to multiply by the conjugate of the numerator in this case, wherever the square root is. So I'm going to multiply the top and the bottom by the square root of x plus the square root of 3. Note that since I'm doing this to the top and the bottom of this fraction, I'm not changing the value of this fraction. However, if you expand the top, FOIL is the acronym a lot of people use, things will work out really nicely. Square root of x times the square root of x is just x. Square root of x times 3 is the square root of 3x. However, the negative of the square root of 3 times x is the negative of the square root of 3x. So those two terms cancel out. And then negative root 3x times root 3 is just minus 3. In the denominator, I also have an x minus 3, and I also have a square root of x plus the square root of 3. So these x minus 3's cancel each other out, and I get this is the limit as x approaches 3 of 1 divided by square root of x plus the square root of 3. This is a limit I can evaluate because this function is continuous as x approaches 3, or at x equals 3. And I can do it by just changing all the x's into 3's. So that's 1 over root 3 plus root 3, which is 1 divided by 2 root 3. Or if you want to show off, you can rationalize the denominator and call that root 3 over 6. I'm good with either of these. Frankly, I'm probably fine with this too, but I'll call these two the answers because here you could simplify it a little bit and write it like that. All right, I guess that's that. That's the last problem on the quiz, so I'll end this video here.